Okay, now we talked about arithmetic mean. If you remember, we had said that arithmetic mean is nothing but if three numbers are in arithmetic progression, say 3, 5 and 7. The middle one is the average of these two, or the arithmetic mean of the other two. So based on this, we have certain problems. So if you see 5 is AM of 3 and 7. You can check it up and see 3 plus 7 upon 2 is 10 by 2, 5, which is the same as this 5. So what do we have in store here? Okay, for example, simple formula as you said, AM, that is arithmetic mean of A and B, is nothing but add them and divide by 2. And remember, another simple common man uses the word average of these two. So A plus B upon 2 is the formula. Okay, now how do you insert arithmetic mean between two numbers? Suppose it has been given, insert two arithmetic means between 1 and 7. The moment, so there are two arithmetic means in simple words, it means that add two more numbers so that all four are in arithmetic progression. So now we need to find how many numbers do you have? We have 4 numbers. So we see that T4 is 7, A is going to be 1, N is 4. You just have to find D. Once you find D, we can find these numbers. So Tn, that is T4, is A. That is 1 plus N minus 1. That is 4 minus 1. And we don't know what D is. T4 in any case is 7. So 7 is equal to 1 plus 3D. So 7 minus 1, 6 is equal to 3D. So D is going to be 6 upon 3, which is 2. So the common difference is 2. That means the first number is A. The second number is A plus D. That is 1 plus 2, 3. The next number is A plus 2D. That is 1 plus 2 into 2, 4, 5. So thus we have introduced two arithmetic means between 1 and 7. It means that 1, 3, 5 and 7 are in arithmetic progression. This is general idea of how to introduce or inserting arithmetic mean between two numbers. Furthermore, we have, say for example, insert 4 AMs between 15 and 25. So we have 15, 1, 2, 3, 4 we need to introduce, and the last term is 25. So if you see, there are 1, 2, 3, 4, 5, 6. So N is 6 and T6 is 25. The first term A is 15. We need to find D. We know Tn is nothing but A plus N minus 1 into D. That is T6 is equal to A, that is 15 plus 6 minus 1 into D. Now T6 we know is 25, so 25 is 15 plus 5D. So 25 minus 15, 10 is equal to 5D. So D will turn out to be 10 upon 5, which is 2. That means the common difference is 2. In that case, this is going to be 15 plus 2. This is going to be 15 plus 2 into 2, 4. This is going to be 15 plus 3 into 2, 6. This is going to be 15 plus 4 into 2, 8. So that is, then hence it will be 15, 17, 19, 21 and 23. So these are the 4 arithmetic means between 15 and 25. It goes without saying, the word arithmetic mean and arithmetic progression are synonymous with each other. Wherever we are talking about arithmetic mean, it means that it involves an arithmetic progression. Right. Okay. Now here again we have insert 4 arithmetic means between minus 2 and 23. We do the same exercise again here. So we have minus 2, we have and 23. So A is minus 2 and 1, 2, 3, 4, 5, 6. So T6 is 23, N is 6, we need to find D. So we have Tn is equal to A plus N minus 1 into D. So T6 is equal to A minus 2 plus N, that is 6 minus 1 into D. T6, of course, the last term is 23 plus 2 is equal to 5D. So D would be 25 by 5, which is 5. That means 5 is being added. So this is going to be minus 2 plus 5. This is going to be minus 2 plus 2 into 5, 10. This is going to be minus 2 plus 3 into 5, 15. This will be minus 2 plus 3, 4 into 5. That is 20. Minus 2 plus 5. Insert 4 ANs. Right. So what do we have? Minus 2, 3, 10 minus 2, 8, 15 minus 2, 13, 20 minus 2, 18, and then 23. We observe that each number is 5. Minus 2 plus 5 is 3, 3 plus 5, 8, 8 plus 5, 13, 13 plus 5, 18, 18 plus 5, 23. So the 4 arithmetic mean taken in order are 3, 8, 13, and 18. They have to be put in order. If you see, the same numbers exist over here, but they are not in order. Hence, we cannot say that these are the arithmetic means. So the only option here is 3, 8, 13, and 18. And yes, we do have it right. Okay. Next in line, we have a situation here. Divide 30 into 5 parts, which are in AP. Again, here we do not know what the first term is, what the common difference is, such that the first and last parts are in the ratio 2:3. Over here, we would like to introduce a concept that if certain terms are in AP, what can we suppose them to be? Suppose there are 3 terms in AP. Suppose we have 3 terms in AP. We can take them as A minus D, A, and A plus D, so that each of them is D more than the previous. This will help because there will be 2 conditions. So they may say there are 3 terms in AP whose sum is 27. So when you add all of them, the minus D and plus D will get cancelled and you get 3A is 27 and A is 9, and straight ahoy we get the first unknown is known. We already find out the value of A. So it helps in taking it, instead of taking it as X, Y, and Z, we take it as A minus D, A, and A plus D. Just as how suppose you take 3 consecutive natural numbers, we don't take it as A, B, and C. We take them as X, X plus 1, and X plus 2. So that it becomes, there is only one variable involved. So much the same way we can take this A minus D, A plus D. Suppose you have 5 terms. What do we take them as? We take them as A, one more less. So A minus 2D, A minus D, A plus D, and A plus 2D. So we have 1, 2, 3, 4, 5. So this becomes a very neat symmetrical arrangement. So whenever we have odd number terms, we take it as A minus 2D. Suppose it is given as 4 terms. 4 terms are given, that is even number. We will take it as A minus 3D. Then we reduces by 2D. So we increase by 2D. So it will become A minus D. And the next term would be 2D more than this. A minus D plus 2D, that is A plus D and A plus 3D. Again, I told you just to help us. Suppose they say there are 4 terms in AP whose sum is so and so. When you say sum, many of these terms get cancelled. Suppose there are 6 terms. When you take 6 terms, we will take it as A minus 5D, A minus 3D, A minus D, A plus D, and the last one is A plus 3D. So, in case of even number terms, we keep a difference of 2D. In case of odd number terms, we keep a difference of just 1D, and you can take this. So coming back to our question, we have divide 30 into 5 parts in AP. So obviously we are going to take them as 5 parts in AP, such that the first and last parts are in the ratio 2:3. So we understand that 30 into 5 parts, that is, these are all the parts of it, so all these on adding give us 30 equal to 30. So if you see all this minus 2d plus d, so ultimately you're left with 5a is 30 and a is 30 by 5, 6. So we already found out the first term, and you need to find out what d is. It's also told that the ratio of the first part, that is a minus 2d, to the last part, a plus 2d is 2:3. You can substitute the value, so you get 6 minus 2d upon 6 plus 2d is 2:3. If you cross multiply, you get 18 minus 6d is equal to 12 plus 4d, and hence you get 18 minus 12, that is 6, is equal to 10d. So d would be equal to 6 by 10, which is 3 by 5. So we have a as 6 and d is 3 by 5. So the first term is going to be a minus 2d, that is 6 minus 2 into 3 by 5, 6 by 5. So 5 6 are 30 minus 6, 24 by 5. The next term is going to be a minus d, that is 6 minus d, that is 3 by 5. 5 6 are 30 minus 3, 27 by 5. The next term is going to be a, that is 6 itself. So we already have among these, so this is going to be 6, 24 by 5, 27 by 5, 6 among these. The only one that seems to be going in the right track is this. So it's going to be 24 by 5, 27 by 5, 6, 33 by 5, 36 by 5. We needn't have to go further and go about doing, because the first three terms already are tallying. So you understand how we can take these kind of terms. So we end up getting 24 by 5, 27 by 5, 6 and 33 by 5, because that is going to be a plus d, and 36 by 5. So the correct option is this. And undoubtedly that will be the right answer. So that's a very interesting case how we can use this kind of a situation. Let's take up more examples based on this. Okay, now here we have divide 144 into 3 parts which are in AP, and such that the largest is twice the smallest. The smallest of 3 numbers will be what? So here divide 144 into 3 parts. So we have a situation wherein we have 3 numbers in AP. So what do we take them as? We take them as a minus d, a and a plus d. So the 3 parts we have is this. If it was 5 parts, you would take a minus 2d, a minus d, a plus d, a plus 2d. Now their sum is going to be 144. So minus d plus d get cancelled. You get 3a is 144. So a turns out to be 48. Right? 144 by 3, 48. Now it is told that the largest is twice the smallest. That is a plus d is twice the smallest. Now we know what a is. So it's going to be 48 plus d is 2 times 48 minus d. So you get 48 plus d is 96 minus 2d. So which turns out to be 3d is 96 minus 48. That is 48, and d turns out to be 48 by 3, 16. So a is 48 and d is 16. So the smallest among them, that is smallest, is equal to 48 minus 16, which turns out to be 32. So the smallest number among these, we can check it up and see 32. We have 32. The next one is 48. And the next one is 48 plus 16, 64. So if you add up all these, 32 plus 48 is 80. 80 plus 64, 144. Ratio of the biggest to smallest. 64 is twice 32. So the smallest among these. So the question is the smallest of the three numbers. If the same question asks what is the largest among the three numbers, it's going to be 64. So our right man here is going to be 32. And we do have it as 32. Right. Furthermore, all right. We have sum of three arithmetic means between A and 22 is 42. So A, we have A and there are three arithmetic means. And this is and 22 is 42. Now we can take A. So we can take it's as if these three numbers are in, let's take this as A or X or whatever it is. So in that case, these three numbers are in arithmetic progression. So we can take them as A minus D, A plus B. Now these three, all these three arithmetic means between A and 22 is 42. So when you add all these, you get A minus D plus A plus A plus D. Turns out to be 42. So 3A is 42. So A will turn out to be 42 by 3, which is going to be 14. So that means A is 14. So in that case, we have A as 14. A is 14, and hence we can, if that is the case, A is 14. But remember what we have taken as 14, we can check it up. Suppose that means the middle term, this one is 14, and this is going to be 22 is actually 14 plus twice the common difference. So D turns out to be 4. So this is going to be 18. This is going to be 12. And hence 12, 14, 22, 18, 14. This is going to be 10. And hence this is going to be 1 less, that is 6. Now, I would like to reiterate, although they have taken it as X, we can even take it as X minus D. Maybe we could take it as X minus D, X and X plus D. So in that case, X turns out to be 14. Let this remain as A. X turns out to be 14. If this is X is 14 and this is 22. So it's understood this is 14. This is going to be D more. This is going to be 2D more. That means it's like telling 22 is X plus 2D. So that is 14 plus 2D. So 8 is equal to 2D. So D is equal to 8 by 2, 4. So the common difference is 4. If the common difference is 4 and this term is 14, so this would be 4 more than 14, 18. This would be 4 less than 14, that is 10. And this would be still further 4 less, that is A. So A's value will turn out to be 6. So this is slightly tricky. They have taken it as A, so candidates can take this as X so that you don't create a confusion with this A and what you have taken it as A. So you can take it as X minus D, X, X plus D. So we can take this as X, X and X plus D. Wherein these three are in AP and we take the first term as X. So once you get the value of X, you know there are two terms between. So the middle term is 14. After that there is one term. So this is going to be 14 plus twice the common difference. From that you find the common difference and hence you find this term and hence the previous term. So A will be 6. And yes, 6 is the right answer. The next situation here is n arithmetic means are inserted between 7 and 71 and the fifth arithmetic mean is 27. So you have 7, 1, 2, 3, 4, 5 and so on and so forth, and there is 71. So this one is 27. So this is obviously A. This is going to be 7 plus D. This is going to be 7 plus 2D. This will be 7 plus 3D. This will be 7 plus 4D. 1, 2, 3, 4. And this would be 7 plus 5D. Because each number is D more than the previous one. And this 7 plus 5D is given as 27. So the normal paradigm about A, B and all varies is slightly changed over here. A is no doubt 7. So this is going to be 7 plus D and this will be the 7 plus 5D, which means it is a sixth term of the AP. So 7 plus 5D. So this gives you 5D as 20. So D would be 20 by 5, 4. And hence D is 4. Now as far as this is concerned, the entire, this is 7, this is 71, that is A is 7 and Tn is 71. So the first information about the fifth arithmetic mean inserted, which is also the sixth term, that has been given to find the common difference. Now we need to find what n is. So we know Tn is equal to A plus n minus 1 into D. In this we know Tn, we know A, we know D. We need to find n. Tn is 71, is A, that is 7, plus n minus 1 into 4. So 71 minus 7, 64 is 4n minus 4. So we have 68 is 4n. So n turns out to be 68 upon 4, which will be 17. That means there are 17 arithmetic means in between them. So that overall there are 17 plus 2, 19 terms in an AP. So n turns out to be 17. So we are getting n as 17. But remember, this n, we could possibly take it as capital N so that we don't mix it up with that n. Okay. Now this n is the total number of terms including the n number of arithmetic means plus the first and last. So which includes the first and last, but n in this case, n is going to be n minus 2. So this question has been deliberately given in such a way that one of the answers has been given as 17. So the moment you get n, you will have a tendency to immediately take part 17. It's not 17 because the n that we have considered for this particular formula includes the first and the last term, whereas the n in the question involves the number of arithmetic means. So the capital and the total number of terms is 2 more than the total number of arithmetic means. So n is going to be n minus 2, that is 17 minus 2, that is 15. That means including 7 and 71, there are 17 terms. So the number of arithmetic means that have been introduced are 17 minus 2, that is 15. Right, so our correct answer is going to be 15 and not 17. Yes, and we do have it right here. So candidates have to be a little extra careful over here, because the moment you tend to get an answer, you're overjoyed that it is tallying with one of them, but you need to take a reality check and check yourself and actually substitute the values and then check it whether which of them is the correct solution to it.